Today we are going to learn a network theory theorems in which we are going to learn Millmans theorem. So Millmans theorem is one of the popular theorem which is normally used to convert any complicated linear bilateral networks into a simplest form and find out the required load current or the power delivered by the load is what we do. So let us learn in detail about Millmans theorem today. Minimizing the number of elements or sources which are being connected in a complicated linear bilateral network into a simplified form and finding out the load current or the power delivered by the load is what we are going to do in every theorems. So now today we are going to learn on Millmans theorem. Okay, so Millmans theorem it can also be applied for DC networks also, but for AC networks is what we see normally. Millmans is much popular for. Okay, now let us look into the statement first. The statement says for AC network, Millmans theorem states that if n number of voltage sources, okay, now for any AC network, if you have n number of voltage sources with its internal impedance, or if the impedance is connected in series with the voltage source, if you have n different such branches which are connected in parallel across the load impedance, then this arrangement may be replaced by a single voltage source, which is in series with the single impedance, which is equivalent impedance, and that is in turn series with the load impedance. So we can convert this entire circuit, whatever we have with parallel branches which are connected in parallel with their load impedance, can be converted into a simplified network which has an equivalent voltage in series with equivalent impedance, and that in series with the load. Now what is V equivalent and what is Z equivalent? According to the Millmans theorem, the V equivalent and Z equivalent is being calculated by these two formulas. So it says V1 Y1 plus V2 Y2 plus V3 Y3 so on plus Vn Yn, whole thing divided by Y1 plus Y2 plus Y3 plus so on plus Yn. So this is the V equivalent what we find out. Now coming to the Z equivalent, we do have 1 over Y1 plus Y2 plus Y3 plus so on plus Yn. Okay, so here this is the two formulas which we use it to find out what is V equivalent and what is Z equivalent, and then we try to write an circuit with V equivalent, Z equivalent, and then that in turn series with ZL. So this is what Millmans theorem says. Use these formulas and to find out what is V equivalent and Z equivalent, and then you will have a load current which we need to find out at the end, where IL will be equal to what? IL will be equal to total voltage V equivalent divided by Z equivalent plus ZL. Okay, so this is how we find out the current, load current. Now here this theorem is applicable only to solve the parallel branch with one impedance or resistance connected to a voltage or current source. The voltage sources can be converted into current sources by transformation. So we use source transformation where we can convert the voltage source into a current source. Now let us look into the proof of this theorem. So let us look into the proof. Now in the proof, what we do have here is, now let us consider a circuit which has the impedance with a voltage source in series with that. So I'll just consider three branches, series branches, which are in turn parallel with the load ZL. Okay, so this is Z1, Z2, Z3. This is V1, V2, V3. Anyway, E and V are same, so sometimes we refer E as voltage and we also write V as also voltage. Okay, so now if I convert this the series combination of voltage in series with Z into a current source, what will I get? I will get a current source. This is done by source transformation. And then I do have a current source. Then I have another impedance here, and then that will be in parallel with the ZL. So this will be what? So this will be I1, which is nothing but we will write it later. So Z1, I2, Z2, I3, Z3, and this is ZL. Here I1, can I say the total current I in this equation would be equal to I1 plus I2 plus I3. Okay, I1 plus I2 plus I3. Now what do we have here is I is nothing but V by Z, right? I is the total current in this particular circuit, which is V by Z. Okay, so now we know that I1 equals V1 by Z1, I2 equals V2 by Z2, and I3 equals V3 by Z3. So if I substitute that, what will I get? I will get V by Z equals V1 by Z1 plus V2 by Z2 plus V3 by Z3. We know that 1 over Z is nothing but the admittance. Therefore, I will say V into Y, which is equal to V1 Y1 plus V2 Y2 plus V3 Y3. So V would be equal to V1 Y1 plus V2 Y2 plus V3, so this is V3 Y3 divided by Y. Now this Y is actually Y equivalent. It is nothing but the summation, Y summation, because when impedance are in parallel, and if you take the admittance of the impedance, we will sum up the individual admittances. Okay, so what would be Y equivalent now is Y1 plus Y2 plus Y3, which is nothing but 1 over Z1 plus 1 over Z2 plus 1 over Z3. So therefore V would be equal to, so this is V equivalent now, this is total V equivalent of the circuit. So this is V equivalent, this is Y equivalent. Okay, so I can say this is V equivalent, Z equivalent, and this is I equivalent. So whatever we are finding out V equivalent is, it is excluding the load impedance. We remove load impedance while finding out the Millmans equivalent circuit. Okay, so therefore it is V1 Y1 plus V2 Y2 plus V3 Y3, whole thing divided by Y equivalent would be equal to Y1 plus Y2 plus Y. So this is what the formula which we get in Millmans theorem finally. Okay, so if you go back and see in the formula what it says, it is V equivalent equals V1 Y1 plus V2 Y2 plus V3 Y3 divided by Y1 plus Y2 plus Y3 if we have 3 branches. This condition is arrived when we had 3 branches in parallel with load. If we have n number of branches, if we have n number of branches, then V equivalent would be equal to V1 Y1 plus V2 Y2 plus V3 Y3 plus so on plus Vn Yn. So if you have n branches, it just gets summed up, and this will be divided by Y1 plus Y2 plus Y3 plus so on plus Y. So this derivation what we did for 3 branches. Now if we have n branches, this is what we to get. Now coming to the impedances, impedance is nothing but, as we have already written, y equivalent is nothing but y1 plus y2 plus y3. Either you can use this formula to find out impedance. Now you find out y equivalent in this, and then you say z equivalent equals 1 over y equivalent. That's it. So this is how we find out z equivalent. Or else we can also say that 1 over z equivalent equals 1 over z1 plus 1 over z2 plus 1 over z. So it is always better you try to use this formula where you add all the admittances and then you take the reciprocal of the admittance, you get the impedance. This is what Millmans theorem, statement and proof. Okay, statement means definition of Millmans theorem and the proof. I hope you understood this. Then now we will go with the problems related to the Millmans. So let me show you the first problem what we are going to solve. So in this problem we are going to find out the current through. So we do have a circuit here where you can see here phi is in series with 10 at an angle 0 degree, 2 in series with 4 j ohms, minus j3 ohms in series with 20 at an angle 45 degree. So we do have this circuit where we need to find out what is the current through this particular 2 plus 4 j ohms. Okay, we need to find out the current through 2 plus 4 j ohms. So now this same circuit I will be writing in a different way. I have a resistance voltage, then I will have 2 ohms, then the impedance, then there is a capacitor in parallel with the voltage source. So this is 10 at an angle 0 degree. Actually this is an arrow will be written in this way. Okay, so similarly here also the arrow is written. This would be 5 ohms, 2 ohms, 4 j ohms. This is 20 at an angle 45 degree and minus j3 ohms. Now we need to find out what is the current through this, which can be an IL, because now 2 plus 4j will behave as load. This will behave as load. So I will write a separate diagram again. I will just replace the position of the branches, that's it. As all are 3 in parallel, I can easily write the parallel branches wherever I want. So that is what I am doing here. So I need to find out IR. Now this is the load which we don't consider while writing the formula. Now we do have only 2 branches in this particular problem. Therefore Millman theorem says V equivalent equals V1 Y1 plus V2 Y2. Only 2 branches. So the equation will reduce to 2 variables, and this will be denominator Y1 plus Y2. Okay. Now this would be equal to V1 is 10 at an angle 0 degree divided by phi plus V2 is 20 at an angle 45 degree divided by minus 3j. This whole thing divided by 1 over phi is y1, 1 over minus 3j is y2. Now we need to find out the solution for this. Okay, so we will take out the calculator. So here 10 at an angle 0 degree by 5 would be equal to 2 at an angle 0 degree. So this minus 3j, if I convert into polar, 0 comma minus 3 will give me at an angle minus 90 degree this whole thing divided by 1 over 5 is 0.2, and this minus 3j, see 1 over minus j can be written as plus j, or 1 over j can be written as minus j. Okay, so therefore this is plus, let me say what is 1 over 3, it is 0.333 j. So this would be equal to, I'll just convert this into rectangular, this I'll divide and I'll subtract this 2 and I will convert that into rectangular. So what will I get is 2 at an angle 0 degree, I'll get 2 plus. Now coming to 20 divided by 3 would be equal to 6.66, 6.666 at an angle 45 plus 90 will be 135. Now if I convert this into rectangular, what will I get? Shift rectangular of 6.666 comma 135. I'll be getting 2 minus 4.713 plus 4.713 j, this thing divided by 0.2 plus 0.33 j. Now if I again this 2 plus 2 minus 4.713 is 4.713, 2 minus 4.713 is minus 2.713 plus 4.713 j divided by 0.2 plus 0.333 j. Now if I convert again this polar into this polar, so both polar if I convert, so again shift polar of minus 2.713 comma 4.713 will give me, the numerator is 5.438 at an angle 119.92, whole thing divided by, if I take the new denominator polar, I'll get polar of 0.2 comma 0.333 will give me 0.388 at an angle 59.010. So therefore now finally this would be equal to 5.438 divided by 0.388 will give me 14.01 at an angle 119.92 minus 59.010 will give me 60.91 ohms, volts. This is actually voltage which we have found, so it is volts. Therefore V equivalent is equal to 14.01 at an angle 60.91 volts. Now my next job is, I need to find out what is Z equivalent. Now if you thoroughly observe here, in this V equivalent I've already found y1 plus y2. Now what is Z equivalent is, so first we'll find out what is Y equivalent. Y equivalent is nothing but y1 plus y2. So after taking this, we got 0.2 plus, this is 0.2 plus 0.333 j, which we have got Y equivalent, and then I converted this into polar form. I got 0.388 at an angle 59.010. Therefore Z equivalent would be equal to 1 over this value, 1 over 0.388 at an angle 59.010. Therefore Z equivalent equals 1 divided by 0.388 will give me 2.577 at an angle This 59, if it goes to numerator, it becomes minus 59.010 ohms. Now this is my Z equivalent. So in the Millmans theorem, we have found V equivalent and Z equivalent. Now what is our job is write Z equivalent and V equivalent circuit now, and that will be in turn parallel with the load. In the question it is given as 2 ohms and 4 j ohms. So we can easily say that it is 2 plus 4 j ohms, and this will be equal to 2 point, or I can say I will write this into this again 2.57. if I take it in rectangle, what will I get here is shift rectangular of 2.577 comma minus 59.010 will give me, I'll just write this in rectangular form. So what will I get is 1.326 plus, so minus 2.209 j. Okay, so this is Z equivalent is 1.326 minus 2.209 j. Okay, so therefore your V equivalent is been found as 14.01 at an angle 16.91 volts. Now therefore the current through the load will be equal to what? Current through the load is IL. So therefore IL will be equal to total voltage V equivalent divided by Z equivalent plus ZL. So this will be equal to V equivalent is 14.01 at an angle 60.91 divided by 1.326 minus 2.209 j minus 2.209 j plus 2 plus 4 j. Okay, so this is what we get. So this is equal to 14.01 at an angle 60.91 divided by, if I add 2 with 1.326, I get 3.326, and if I subtract 4 with 2.209, I get 1.791 j. So this would be equal to, I'll convert this rectangular to polar again, which will give me 14.01 at an angle 60.91 divided by polar of 3.326 comma 1.791, which will give me 3.77 at an angle 28.30. Therefore the current IL is now finally equal to 14.01 divided by 3.77, which is 3.71 at an angle 60.91 minus 28.30, 32.61. So this is what the current IL, load current, which we have found just for this particular problem. So finally I'll repeat just the steps. So what we did is, this was the given question here in the Millmans theorem. They asked to find out the current through 2 plus 4j through Millmans theorem. Therefore the 2 plus 4j in the circuit becomes a load impedance. Therefore what I did, I have just written the circuit in a different format, where I took 2 branches separately and load impedance I have connected at the end. Then as we have only 2 branches, so the Millman theorem says V equivalent equals V1 Y1 plus V2 Y2 plus divided by Y1 plus Y2, because only 2 impedances which are connected in branch which are connected in parallel, what you can see only 2 branches. So this is the formula. Now we found what is V equivalent with this particular calculation, and then Z equivalent we have found Y1 plus Y2 in V equivalent, which is nothing but Y equivalent. So that Y equivalent is nothing but 1 over Z equivalent, or Z equivalent equals 1 over Y equivalent. So when you solve it, you will get Z equivalent is this. Now that Z equivalent is being converted into rectangular form. and then you will write the Millmans equivalent circuit here, where all the three components are in series. Then you will find out what is the load current IL through the formula V equivalent by Z equivalent plus ZL. So therefore, V equivalent divided by Z equivalent plus ZL will give me the final current, load current would be equal to 3.71 at an angle 32.61 amps. Okay, fine. So this is what the solution for this problem. Okay, now we'll go with the next problem. Now this is the problem which is given here. Again, write the Millmans equivalent circuit is what the question, and also find the current through load. Also find the current through load. So this, in this particular problem, you can see that 2 plus 4 is again a load here, where I need to find out the current I, and we have given this circuit. Now if you clearly see this problem, you have these two branches which are connected in parallel. These two branches which are connected in parallel, where you can see a current source in parallel with the resistance. First you convert that into a voltage source in series with the resistance, and then we'll see three branches which are in parallel, where each branch has a voltage source in series with the resistance. Then we'll apply Millmans theorem. So therefore what we'll do is, we first convert this parallel to series. So what do we get? A circuit here. So this is in parallel with the impedance, what you can see. So here 1 at an angle 0 degree is this 1 ohm. Then I have 5 at an angle 0 degree volts, and again 1 ohm. Now here if I convert this into, so all these are flowing upwards. Now if I convert this current source to voltage source, then V equals I into R. So I do have 25 into 5, which becomes 125 volts, and this is 5 ohms, and this is remains as 2 ohms and 4 j ohms. And this is the load where I need to find out what is load current is. Okay. So now according to Millmans theorem, if you try to work on this, we can see that there are three branches here. There are three branches. Therefore V equivalent will be equal to V1 Y1 plus V2 Y2 plus V3 Y3 divided by Y1 plus Y2 plus Y3. Okay, now what is V1 here? V1 is nothing but 1 at an angle 0 degree. So this will be V1, this will be V2, this will be V3, and this will be Z1, Z2, Z3. So V1 is 1 at an angle 0 degree divided by Y1 is 1 over Z1 divided by 1 ohm plus V2 is 5 at an angle 0 degree divided by 1 ohm again plus V3 is 125 at an angle 0 degree divided by 5. This whole thing divided by Y1 plus Y2 plus Y3 is 1 over 1 plus 1 over 1 plus 1 over 5, which is 1 over 5. I can say this is 0.2. Okay, so this will be equal to, at an angle 0 if I write, it is nothing but 1 by 1 is 1 plus 5 by 1 is 5 plus 125 by 5 is 25. This whole thing divided by 1 plus 1 is 2, 2 plus 0.2 is 2.2. This will give me 31 by 2.2. So this 31 by 2.2 would be equal to 31 divided by 2.2 would be equal to 14.09. So therefore V equivalent equals 14.09 volts. So we got V equivalent. Now to find out Z equivalent, first we'll know, we already know what is Y equivalent, which we have already done in this particular V equivalent while finding out V equivalent. y1 plus y2 plus y3 is 1 plus 1 plus 0.2, which is equal to 2.2. Therefore, z equivalent is equal to 1 divided by 2.2. Therefore, I get z equivalent to be equal to 1 divided by 2.2 will give me 0.5. 0.5 ohms. So I got V equivalent, I got Z equivalent. Now what I'll do is I'll write the Millmans theorem circuit. So therefore I will have V equivalent and then Z equivalent, and then I will have a load which is connected here, load. So here V equivalent which we have got is 14.09 volts. So we got 14.09 volts. That is what V equivalent we got. Z equivalent we got 0.5 ohms. And then load is 2 plus 4j ohms. Now we need to find out what is IL. So IL equals V equivalent divided by Z equivalent plus ZL. So this is ZL, this is Z equivalent, this is V equivalent. Therefore what I will get here is 14.09 divided by 0.5 plus 2 plus 4j. Therefore IL would be equal to 14.09 divided by 2.5 plus 4j. So therefore IL would be equal to 14.09 divided by, so if I convert 2.5 plus 4j into polar, 2.5 comma 4 would give me 4.71 at an angle 57.99. Therefore IL would be equal to 14.09 divided by 4.71 would give me 2.99 at an angle minus 57.99 amps. So this is the current IL. So fine. So this is what the final solution which we need to get for this problem. So here again I'll repeat. So in the problem it was been asked to find out what is the current through the load terminal after finding out the Millmans equivalent circuit. So here 2 plus 4j is the load where I need to find out the current. For that we had a parallel combination of current in parallel with the resistance. I have converted now that into a voltage source in series with the resistance, and then we saw that we were able to see that there are 3 branches where you see voltage source in series with the resistance. Therefore, the Millmans, according to the Millmans theorem, now V equivalent would be equal to V1 plus Y1 plus V2 Y2 plus V3 Y3 divided by Y1 plus Y2 plus Y3. With this I found 14.09 is V equivalent, and then we have found already Y1 plus Y2 plus Y3 in V equivalent, which is 2.2. Therefore, Z equivalent would be equal to 1 over Y equivalent. So I got 0.5 ohms. Now I am going to put that here in the circuit, which is Millmans equivalent circuit, where V equivalent, Z equivalent and ZL all 3 are in series. So finally IL has been found by using V equivalent by Z equivalent plus ZL. Therefore finally I will get the current IL to be equal to 2.99 at an angle minus 57.99. So I hope the Millmans theorem explanation along with these 2 problems is clear to you.